Good evening, everyone. Welcome to the Azure Cleveland User Group. My name is Sam Nasser. A little bit about the Azure Cleveland User Group. We meet every second Wednesday. The meetings are free of charge and open to the public, and we cover a variety of topics related to Azure, whether it's infrastructure as a service, platform as a service, or software as a service. You can find all the meeting information posted at meetup.com for both past as well as future meetings. I'd like to give a big thank you to our sponsors, PostSharp and DevExpress, for sponsoring the post-meeting prizes that will be given away using the eval form. I would also like to thank the .NET Foundation for sponsoring the Meetup website. And last but not least, NIS Technologies for sponsoring the virtual meeting space. Also like to give a big thank you to Manning.com. They're offering a 35% off offer on a selection of books with a discount code and the link listed in the slide. And that will also be posted in the chat window shortly after the presentation. If you're joining us for the first time, please keep in mind participation is encouraged. And like I always say, the only stupid question is the one not being asked. So feel free to jump in with any questions or comments. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And we want to keep it casual but organized, meaning jump in with questions, but at the same time, we want to give our presenters enough time to go through the slides and the demos. And lastly, the meeting is being recorded and will be posted on YouTube in just a few short days. And so with that, we'll launch into our feature presentation. Tonight we have Martin Bald and Jeff Will from Wallaroo, and they're going to be presenting on Wallaroo and how we can bring a machine learning model to production faster. And so with that, let me turn it over to you, Martin, Jeff. Thank you for joining us.
Great. Thank you, Sam. Thanks, Matt, and everyone else that joined today. I really appreciate you taking the time out your day to be part of this session that we have. And also, Sam, thanks for inviting us here. It's great to connect with the community. And I think, one of the great things that, probably one of the good things that came out of COVID was that we can do these things virtually. And, it's great to be in person, but having these virtual events, it really extends the net and gets folks from different parts of the country engaged in the community. And it's good to be talk to folks about AI, and there's a lot of energy around this. I also have my colleague Jeff Will with me. Jeff's a senior product manager at Wallaroo. He's a goose to my maverick, so to speak. He's very technical, a lot more technical than I am, and so he's here to help with Q&A and on the background. So thank you, Jeff, for your support. So as Sam mentioned, to begin with, what we want to cover today is essentially helping data scientists, MLEs, ML engineers, or data engineers, or anyone that's working with AI models to go quickly from that pre-production space into production. And so we'll cover off some of the challenges there. I'll introduce myself, who we are and who Wallaroo are, and then we'll spend the bulk of the time going through a demo, and this is how we see things, and how we've sort of looked at the challenges that some of our customers and other community folks have faced. And then we have some resources that you can actually get some hands-on with. And then, as Sam mentioned, we can do Q&A at the end, but please, we want to keep this interactive and engage with everybody. So feel free to ask questions as we go through. So who am I? So sorry if this picture scared you. They make me put these up, but essentially, my name is Martin Bald. I'm the senior manager of the AI community at Wallaroo.AI, and I've been very fortunate in my career. I've spent over 2 decades in the tech industry. The bulk of that was with Microsoft. And so I came from field roles in the Canadian sub to corporate, working with partners and developing partner practices for the cloud. And then my most recent role before I left the company was in evangelism, which is now DevRel, and working with folks in the community like yourself on a number of different engagements and upskilling and sharing ideas through that. And some of them were things like the Imagine Cup. I was a student program manager for that community. I also ran open hacks with IoT, and it was always great to see how folks like yourselves can take, the technology and apply it to the solution, and the creativity that went with that. And that was the part that really, I enjoyed most, was seeing what people could do with technology and how they can overcome, challenges. Whether that be in business or for other technology uses, such as tech for social good, for example. So great to be here. So who are Wallaroo? We are a Series A startup. We are funded by the Microsoft N12 group. And we're also a Microsoft partner. We're part of the Microsoft for Startups Pegasus program as well. And essentially what our product does is it's a production AI software platform. And so we help companies and businesses take those models from that pre-production stage into production, and not just deploying them into production, but then giving the data scientists and the ML engineers the self-serve capabilities with which they can then make sure those models are performing the way they were intended to, through capabilities such as observability, being able to optimize models through things like A/B testing, shadow deploy, and then also pushing those updated models into production on the fly without taking down that environment. We also have the capability as well of orchestrating that workflow, so that if you have models that are just running in batch process, you can schedule those and you can monitor that, you can generate reports and etc. And that all extends out to the major clouds that we'll cover Azure ML here today. But also we deploy to not just the 3 major clouds, but also on premises. And most recently, we've been deploying to Edge AI, as that has become more popular, and the capabilities of these edge devices. We can run models, we can run observability, and decentralize the running of those models in those edge or multi-cloud environments, all while retaining the centralized operations control within the product. And so that's who we are, and we've been pretty successful so far. We're on a good trajectory despite the bumps that everybody experienced in the tech industry in the last 12 months. So today, what I'll cover is looking at getting to production from that development stage. And essentially, we'll look at the space within this red box here. There's a number of things that go on before you even get to deployment. You got to prep your data, whatever use case you're running in, whether it be classification, regression, computer vision, etc. The data scientists develop, they train that model on their sample data set, and once they've done the evaluation, the next step is to get that into production. Get it working for the company and making sure that it gives that value back from all the effort and energy and time that has gone into that. And so that takes a significant step to do that. And sometimes it's not always successful. If you've seen any of the Gartner reports, you'll see that I think it's about 80% of businesses fail to get their models into production. So that's a significant hurdle for organizations. And sometimes production is not in the mindset when we go through the development phase either. And so making production part and parcel of that whole ML and AI lifecycle is super important to the success of the model and the project. The other element is, from deployment, that leads down to the things I talked about before. For observability, making sure that you're checking that the outputs of those models are what they're meant to be, and then orchestrating them so that you're less hands-on and you spend more time working and optimizing that framework, all without being a burden to the IT ops and DevOps people that are running all the other tasks and demands on them from the business. So that's what we'll be focusing on. We'll focus on how we get from evaluation into model deployment. And the challenge that we've seen when we talk to customers, when we engage with community folks like yourself, is that the expectation is that data scientists and ML engineers or data engineers they have that, there's an expectation for them to be full stack engineers. They need to learn, they need to know all those tools that are associated with not just experimentation, but also production on that other side. And so working with those different tool sets, those different infrastructure tools, Docker, Kubernetes, model frameworks, etc. It takes a lot of time because you've got to go learn that. If you're not familiar with it, you got to manage that as well. That's not something that's in your default skill set. And the downside of that is that it takes away the time from developing those models further, really optimizing them, monitoring those models for things like drift and making sure that, what you have out in production is the best possible model that you can create. And so we see, a number of different common model frameworks, PyChart, sklearn, XGBoost, TensorFlow, etc. And then on top of that, you got to manage all that infrastructure as well. And as I mentioned, you don't want to be that burden, to the IT folks also. And so when we looked at this and when we talked with our customers, the sense that we get from that and what we sort of thought about, okay, how do we solve this problem? And so this is how we look at it. We looked at it like, how can we self-serve? How can we help data scientists and ML engineers be much more self-sufficient in, deploying that model quickly, efficiently, and then also with the least amount of code involved in that as well. And also bringing in the flexibility of using different model frameworks. People might be familiar with, certain model framework types. They might have certain environments or certain teams might be working with different model types. But how do we standardize that process and getting it into production and not have to jump through, hoops or hurdles to get them, to that point where they're actually working on behalf for us. And the other element, as I talked about, is the IT and DevOps. That dependency that, we have to make a request to them that, we're a burden to them, and that comes part and part to the self-service capabilities, is making sure that, they are involved in everything we do from an infrastructure standpoint, but they're not a blocker. They're not a dependency on us getting to production and reducing that overhead, and that gives us more bandwidth. If we can reduce the time and investment that it takes for folks to get these into production, it means that we have more time and bandwidth with which to work and optimize our models and create new models for the business. And so that's what we're looking at today. So we'll go through an example where typically, different departments, as I said, or different people might work with different model frameworks. In the development stage, you might have sklearn, TensorFlow, XGBoost, or whatever, depending on the use case, dependent on the environment or whatever project you're working on. And then what we look to do is part of that solving the problem is auto packaging. And so we help auto package that model for production and then environment that it needs to go into, for resource considerations, whether it be in the cloud, on-prem, or on an edge device. And then the self-service capability comes in for the self-serve. That allows those data scientists and ML engineers to deploy these into production themselves and be self-sufficient and manage that whole process without having to manage a whole whack of infrastructure as well. And they can deploy that easily out to any deployment target that they need to. So what we'll do is let's have a quick look at what does this look like. So I'm just going to pop out here. Hopefully it's still running. So what we're doing is we're inside Azure ML, and so we're running the Wallaroo SDK, and so the Wallaroo SDK is running inside Azure ML, and so that's one of the capabilities I talked about at the beginning, is helping extend the power of technologies and services like Azure ML. And so within the SDK, we also have a UI capability if you're more familiar with working in a UI. And we have a whole bunch of APIs as well, which you can leverage as well. But for this example, we're using the SDK, and we're using notebooks as well inside Azure ML. And so I have my I have my instance running inside Azure ML here. And so what I'm going to do to begin with is I want to, preload, some of my, libraries and other things that I need, for Python to, be able to, run the other commands that we need. And so this takes a couple of seconds here. And next, what we want to do is we want to connect to the Wallaroo client. And so I'm already logged in, but essentially you saw a little URL there, but essentially what it's doing is it's then connecting to that Wallaroo client from inside here. And if I had the URL, I'd click on that and it would say, yep, do you approve this? I would say yes. And so we are now connected to the Wallaroo client. That's my demo POV, and that's the precise instance that I'm connected to here. So what we want to do next is we want to then set up our workspace. Now for this example, we're going to focus on a regression problem. And so we're going to use the open source house price, Seattle house price prediction model. And so that will give us a set of features about a house and allow us to estimate the cost of that house. So that could be number of bedrooms, bathrooms, square footage, is it detached, semi-detached, etc. And so that's all available in that free model that's up on Kaggle. And so in a typical scenario that you might get in a business at this stage is you might have a bunch of different models that have been trained. And so deploying them requires you to, set up a separate environment. You need to set up separate Docker files to containerize this model. And there's going to be other folks, as I mentioned, on the team developing other models as well in different frameworks. And so you could have a variety of models to work with in that development environment. And that can all lead to some confusion. It can lead to delays and disconnect within that process and slow down the path to production. And so what we want to do here is, now that we've connected to our client, we want to create a workspace. And so the workspace will then be that sort of location which will house, no pun intended, all the artifacts for our production projects. And so we're going to run this. And so now we've created a workspace. My workspace is this name here. And if we were in the UI, you could actually go in and look at that and any models or pipelines that were within there. Now we will be working in this example with a TensorFlow model. And so we'll use this deep learning TensorFlow model. We're going to upload this model method from the client, and then we're going to pass that model name and the zipped model path, and then define that framework. And so you can see we have that framework defined here. We have our zipped up file also, and we're going to use the upload command. So we'll run that one. I'll scroll up a wee bit. So now we've uploaded our model. Again, that took like 2 seconds, a couple lines of code, and our model is ready. And so in the workspace that we created, we've uploaded our model into that workspace. Now, the other thing that it's done here as part of this process is that this model is now available in our model registry. And the model registry is very important because what that does is it helps facilitate seamless model management through sharing, versioning, tracking of models. This also helps AI teams and ML teams to collaborate more efficiently, helps them experiment faster, and then also deploy with confidence better models into production. And so, as I've talked about a couple of times here, you might have those different models, different versions of the same model, ones that have gone into production. You've taken that model and you've continued to iterate and work on that model, and you want to get that into production. The registry will then be able to show you which version of that model you're running in production and what the history of that is. So now that our model is uploaded, we want to deploy this to production. And so what we're going to do here is we're going to define our pipeline, which is our TensorFlow house price prediction. And then what we want to do is then step through and deploy this. Now we have the control here with which we can, make sure that we can, choose the deployment configuration. So we can set the resources for this pipeline. So we're going to make it, a replica count of 1. We're going to have 1 CPU, and we're also going to deploy it with 2 gigs of memory. Now this is important as well. Again, giving you the control to do this from a couple of lines of code. But if you're looking at deploying this to remote devices like edge devices or different, multi-cloud endpoints, it's important to, make sure that you don't want the finance people or the DevOps folks, IT ops folks coming on your back saying, hey, what's this thing racking up all this, these costs in, the subscription. Also, if you're deploying out to an edge device, these devices have limited resources. So you want to make sure that you're optimizing the resources on those devices just in case they're running more than one model. So we have control here to choose, CPU and our memory count. It could also be GPUs or ARM processors. We also support those as well. And so we're going to build our pipeline, and then we'll deploy that into production as well. So this takes a couple of seconds to do, and we are in production. We've taken our model from that pre-production stage. It's been auto-packaged. We've established the resources environment that we want to deploy it to, and it's up and running. So we can see that our model is running now. It's live. And so the next thing we want to do is say, okay, well, if it's running, let's test this out. So we want to check the status of the model to double check, just let's make sure that it's running, even though it says it is. So we're going to send some sample data to this, and that'll help us check the status. So we'll run like a single data point through here, and we can see that was successful. And then we're going to put this into a data frame as well, so that we can get a table output. So if you can imagine, you might have, in this case, we've only got one item because it's one data point, but just what if you have like 1,000, houses that, in your data set, or 2,000 or whatever it is, you could tailor that by your zip code or other region, dictation. And so we've converted this into that table format, and we can then see the output results. So our average house price here, or the house price for this one data point, is like 1.1 million, and we have no failures either. And so it's important as well from a logging perspective, and if you want to do any anomaly testing or that, you want to see if there's any failures that pop up. Now, the other thing that's available to us is that we can run the pipeline URL command here. And so what this allows us to do is it helps us then expose the endpoint as a URL. So what we can do here is we can then integrate that URL into an application. And so we can extend that into an application. It could be web page or like an app on a mobile phone or something like that as well. And so what we have here is we've got a working model. It's in production. So we've taken that from like a couple of minutes without me jammering on here. You probably get this into production in less than 5 minutes. But you've also not had to go through the hoops of having to learn that infrastructure and configure the infrastructure, manage Docker, Kubernetes, or any of that other overhead. We have the flexibility with which we can choose the environment that we're deploying to. In our case, 1 CPU, 2 gigs of RAM. Our model, again, doesn't matter what model we have, we auto-packaged and got that out to production. We're able to start inferencing on that model in a matter of minutes. And so that's a huge time saving that then goes back to the data scientists and the MLEs that are now sort of running those projects from development into production. They can carry that model that they've worked on right through those different stages and manage them. And now they can go on and start running observability or orchestration and testing other models and putting them into production. And so that's one method that we looked at and we thought, okay, how can we make this easier for folks to get to production? The other thing is that while we have the different sort of models that we support, and I'll just quickly kind of go off-roading here a little bit here, but we've got I've got my models folder. So this is our TensorFlow model. We've got our XGBoost model. We could have other models in there like sklearn and so on. So we support a whole number of different common model frameworks like Onyx, Keras, XGBoost. We also integrate with Hugging Face frameworks, for example. And so anyone that's sort of living under a rock for the last 12, 18 months, the Gen AI wave that is just taking over the industry. There's a ton of great models out there, and you want to be able to take them, try them out. And the great thing about taking these open source models is that it gives you a leg up the ladder. You can take those models, get a few steps up the ladder, train them, tighten them up, hone them in for your own uses and needs. Now, there's another approach as well, another situation that folks might find themselves in the production environment. And this is custom frameworks. And so while we accommodate those common frameworks that I mentioned, like Onyx, Keras, XGBoost, etc., there's also custom frameworks that are, lie outside of that. And with custom frameworks, we can accommodate that sort of situation as well. And so this could be any sort of Python code that does some sort of pre or post processing in a non-common framework that is not one of the ones that we're familiar with. So the benefit of this is that you can bring any model framework here. And then you can also run other processing on that model framework, whether it be some other reporting code, like a pre-process, post-process, etc. And so these are referred to as custom inference pipelines. The other sort of term that you might hear them called is sort of BYOP, bring your own predict. And so what we're going to do is, for the next sort of example here, is we'll show how that works. So we are using a common model here, but again, this could be any model framework. And so what we're going to do is we're going to wrap this model inside, with some Python code. And essentially what we're going to do here is, actually I've already got it up. So we have our requirements text, and we also have our main.py. Now within the main.py, these are very similar steps to that we'll go through as what we just saw in the TensorFlow example. But here we have our inference builder. So this will help us establish the sort of inferencing of the model. And then we also have our post-processing command here as well. And so what we've wanted to get out of this post-processing output is that we want to, set this up and cap the value at 150K just for this example. So, I don't know any house in the Seattle area that it's like 150K, but let's see, we should hopefully get one. But essentially, this is all wrapped up. This is that wrapper code that will go around our XGBoost model. Now, I've pre-run this. It can take anywhere up to 10 minutes. And, I don't want to sort of, put you through that. But essentially, you can see, again, it only took like, less than 2 minutes for us to, go through. We establish our schema here, and same process and steps. We, establish our framework as well in these commands. And we saw exactly the same code that we did for the TensorFlow model. Then we want to custom, we upload this custom inference pipeline. And again, that same process here. we have our zip file path, and then we're also establishing that this is our custom framework. And I've pre-ran this one as well, just because, again, could take up to 10 minutes. I think it took me about 5 minutes earlier on today, but it's about 2.5 minutes. Now, I'll skip the next command, but essentially what we're going to do now is the same steps that we saw in the TensorFlow model. So we establish our pipeline, and we have our custom model as well. And then we go through the same deployment config. And this time, again, we have the flexibility of choosing, hey, we don't need a whole CPU. We're only going to use like a quarter of that resource, which is ideal. And then we only need 1 gig of RAM as well. And then we're using our pipeline deploy command. And so, oops. And this is where I need my colleague Jeff to come in. So,
did you upload the model already?
Yeah, it should have run.
It looks like that is old callback. It has number 6 next to it versus the 17 on the next one.
Oh, there you go. Okay, let me go. So apologies for that, folks. But essentially, this is running. Hopefully, if it takes a couple of minutes, then we'll get to see this. But as I talked about, while it's doing this, we have the capability here to choose what we environment that we want to. And so, just to sort of give you a story, we had I ran a project with a grocery outlet, and what they were doing is they wanted to have edge devices, and they had cameras to look at fresh produce. And so with that produce, if the bananas went off or the fruit went off, they wanted to be able to have that AI capability of helping staff to rotate the stock or take old stock off without them having to get by every hour or so on. And so those environmental conditions were different for every store, because you had stores in humid areas and colder areas like maybe Cleveland in the wintertime, or the Northeast. And so those different environments can affect the produce. And so what they did there was that we were able to deploy those models into those edge devices. And the issue that we had there was that all that sort of CV image capturing had to be sent right up to the cloud in order to be processed. But now what we can do with the power of these models on the edge is that we can then process all this on the edge device. And so we can see that this is finished running. So I'm going to run this again, and it's not running. Anyway.
Did you run the command right before that too? The custom after the upload, but before the scroll down.
Oops. Sorry.
There is no after that. There's a command that assigns like the latest version. Yeah. Did you run that one? And it's still giving you.
Yeah, I don't. We'll see it. And I didn't run that before.
Okay.
Looks like that one's running. Yeah, thanks, Jeff. Appreciate that. Yep. It's funny because I didn't need to run that before. But anyway, so what we have here is now, again, like in 3 seconds, despite me messing this up, is that we've deployed this model to production. So we can see, hey, it's deployed, it's true, and we can see any other versions and so on. And so now what we want to do is we want to then run through the same inference process that we went through before, and we'll send 1 data point to this. And so we can see that our output, remember we put that post-processing cap of 150K, so we can see that this is our output. So it's given us that post-processing that we established in that custom code. And then again, no failures as well, which is always great to see. And so essentially what we've seen here, like in a few minutes, I've deployed 2 models in a production of different times. We have a TensorFlow model, and so through that capability of auto packaging really helps take away that burden for data scientists or MLEs or anyone working with machine learning models and trying to get them into production, and really making it easier. And I'm sure there's different ways. I think the great thing about, the community that we're part of is that this is how we see it. This is, from the conversations we had with customers and other folks in the community, this is how we approach this issue. And this is how we think about it and how we help solve this. But I'm sure there's other, folks that have come across something similar and maybe taken a different approach. And I'd love to hear of different experiences that folks have and how they've managed to tackle this. So let me go back to my deck right now here. And so essentially we went through all this. We deployed out to those, endpoints. We ran the pipeline URL and we got that URL which we can then expose in applications. Is there any questions right now maybe that we can answer? And apologies for me messing up that last demo.
I have a question for you, Martin.
Yeah.
Is there any way that you can automate the evaluation of the model to where if it doesn't meet a certain criteria, you could retrain it and bring in more data until it meets a certain criteria for the evaluation process?
It's a good question, Jeff. Maybe you would know. I think just one of the things that we don't come across, unless Jeff, you have with customers, is that because we are production AI, we don't get too involved in that pre-processing or that pre-production stage of model creation and so on. But I think what we can do, and I mentioned it briefly, but while we're not testing or pre-development, and we are production AI, what we do have in terms of capabilities is to A/B test a model and then or shadow deploy. And so you can take a model that you've developed, and so you might have, just say we take, I don't know, computer vision or something like that, right? So you might have developed a model and you're like, hey, what, A, this is more accurate, we think. B, it's lighter weight, and so it requires less resources. And so you can go through the same process that went through here to go through A/B testing. So you can then pitch that model up against the model that you have in production, and then you can then measure the performance. So you might say, hey, this new model is performing much better than the one that we have in production. And then what we have within the product is the capability with which we call it hot swapping. So you don't want to have to, let's decommission or dehydrate this model in production and then go through the rigmarole of putting another one up, right? You hot swap those models on the fly, which is great if you're running streaming models. Those things are instantly switched over. So something like fraud detection, you don't want any downtime in the running of that model. You want that model to be up, all the time. And so what that allows you to do is to take that model that you worked on and put it in production. So again, while we don't get into, pre-production, you can take, those models that you have developed and, put them up against other models, again, through A/B or shadow deploy. Does that help answer? Or Jeff, do you want to weigh in?
Let Sam answer first.
Yeah, no, that does answer my question. Thank you.
Great, thanks. Any other questions? No, well, if there are, I know people are, sometimes it's not easy, but yeah, what you can do is, more than happy to sort of take any questions, after the fact as well. My email is here at the bottom, and so you can email me. You can also look me up on LinkedIn, and a couple of other things that we have is being the community guy. It's sort of my job to sort of reach out and helping engage folks, and so I just put this in the chat as well, but we have a free community edition, so that license doesn't expire, and you can install it to Azure, AWS, GCP if you want, but we also have capability of installing it Hub Code Spaces. If you're not familiar with Hub Code Spaces, I think it's about up to 60 hours a month you get of free sort of cloud, resource time. And so, you can it's not everybody that has access to a cloud instance. And so what you can do is you can deploy the Community Edition up to that GitHub code space, and then you're up and running, right? And so what you can also do as well is, I just put this in the chat, is you can go to our docs, .wallaroo.ai. And so the demo that I went through today, we have that, we call it BYOP, but yeah, we have auto packaging, the BYOP, we have a ton of other tutorials that you can go through and learn and get hands-on. So as you talked about, Sam, we have A/B testing tutorials, shadow deploy, and also different use cases, classification, regression, computer vision, LLMs, etc. And we also have a hands-on workshop. So, we take away some of the code if you want to get a bit more challenging, and you can actually type in, the code yourself and go through that. You can all do that all from the Community Edition that is available. And we also, on the Azure Marketplace, because we are a Microsoft partner, we have free inference server. We have about 10 different, common AI use cases. Again, like we have Hugging Face models, we have YOLO, CV, ResNet, and we just uploaded the health one that does image recognition for brain tumors as well. So these are great ways in which you can sort of try out and get hands-on, do some learning, and then see is this something that you kind of enjoy doing? And again, I'd love to hear from people. As I talked about at the beginning, it's been great to be part of the community, and the great thing about being with Wallaroo is that getting to talk to folks that are looking to deploy or working with models in the AI space. So yeah, please don't hesitate to hit me up. So yeah, again, thank you very much for your time. Thanks, Sam. Thank you for the invite. I really appreciate it. And also thanks to the sponsors that help contribute to these events so that they can happen. And thanks to everyone that showed up. I know it's well after 6 o'clock and probably in your dinner time out on the Eastern time zone. So thank you very much. Really appreciate you taking the time out to be here today.
Thank you, Martin. Highly appreciate it. And likewise, Jeff, appreciate your being here as well. And really like what you guys have to say. Very interesting product.
Yeah, thanks very much. And if you do want to invite us back, we can actually, we could go through an A/B testing or orchestration like other examples if you want in the future. Happy to do that.
Absolutely. Welcome back at any time.
Thank you.
All right. Want to take a moment and pause for a second and ask, are there any questions or comments? Feel free to either jump in verbally or enter them into chat. And if not, what I will do is I will go through a couple wrap-up slides, and we'll conclude tonight's meeting. In the meantime, there's a couple links that I posted in the chat window. If you would please take a moment to look at that, and then we'll go through them in just a second. And so the links posted within the chat, you have the link to the YouTube channel. The meeting is being recorded and will be edited in a couple days and posted on the YouTube channel. So if you would please subscribe to get upload notifications. Likewise, tech events will be posted on my blog, and you can subscribe to that to get the updates. And last but not least, the feedback eval. If you would please take a moment to fill that out so we can provide Martin and Jeff some constructive criticism.
Yeah, any feedback so that we can make these better is always welcome. Thank you.
Absolutely. Thank you. For those of us that joined us after the start of the meeting, we have a special offer from Manning.com for a 35% off a selection of books. Both the discount code and the link are posted in the chat window. And like we always do, always like to ask who's hiring and who's looking for work. So if you would please make yourself known either verbally or in chat. You can always check out techsystems.com/IT-jobs. They always have job postings posted there. And likewise, if the need arises, feel free to email me, snasser@nistechnologies.com. You can also find me on Twitter and the link to my blog once again. And lastly, if we're not connected on LinkedIn, I invite you to do so. And so with that, thanks again to Jeff and to Martin and all those that attended, and look forward to seeing you all next month. Good night, everyone.